So we will discuss the derivation in work energy and power. So first write down first derivation of kinetic energy. Topic you write down work energy and power derivations. First write down derive the expression for first write down question number 1. Derive the expression for kinetic energy. Ke means kinetic energy. Derive the expression for kinetic energy or prove, question may be, or prove kinetic energy is equal to half mv square, where m is what? Mass and v is velocity. You note down this. So write down, in answer you write down. If you know, you can try, otherwise you write down. Let us consider an object having mass m, comma, initial velocity u, and after the application of force, its velocity changes to v. V represent here final velocity, u represent initial velocity, m represent mass, and f represent, you write down here, f represent force. Now you draw the diagram. This is the surface. Suppose this is an object. You draw it. After some time, with the application of force, it comes to this part of this road. You draw it. Its mass is m. Initial velocity is what? U. Now when you apply force, with the application of this force, its velocity changes to v, and it covers some displacement. From here to here it displaces. So how much it displaces? Suppose this displacement is s. Okay, now you know the formula for work. What is the formula for work? Work is equal to force into displacement. Write down force into displacement. And displace, what is s here? You mention here s is displacement. A is what? Acceleration. Write down A is acceleration. Okay, so no need to write your displacement, you just write s. S represent displacement. And W represent what? Write down here, W represent work. W is work. Okay, note down everything. You draw the diagram also. Roughly you can draw, no problem. Now you know the work formula, force is equal to ma. This you learn in chapter number force, that is chapter force and laws of motion. Force formula is what? Ma, and it is displacement, that is s. Now you have to put the value of a here. So you know v square minus u square is equal to 2as. So what is the value of a here? So a will be what? A will be v square minus u square upon 2s is the value of a. So equation number 1, equation number 2. Put the value of a here, you will get work. So put here, put the value of a here from this table. So what is the value of work? Work will be, W represent work, m into bracket you have to write v square minus u square upon 2s so you have to put the value of s here, not a. Okay, so that it will cancel because there is s here, it is s. So better you write here only one, you have to change one thing, only you have to change it. Here you have to write a and here you have to write s. So write here s and a, no problem. So what is the value of a here? So you have to write m a is what? V square minus u square upon 2s. So write here 2s. Are you getting or not? Force formula is what? Force into, work formula is force into displacement. Force formula is m into a. Here it is displacement. So we have to remove this displacement. For that we have to use the second kinematic equation, that is v square minus u square is equal to 2as. With this formula we will get v square minus u square upon 2s. So we will find the value of a. So a value will be v square minus u square upon 2s. Both will come in denominator. Okay, so now put the value of a here. A is what? V square minus u square upon 2s. V square minus u square upon 2s into what? S. So multiply here s. So this s will cancel. So you will get work as half m v square minus u square. So this is the work. Note down, this is work. M is common, you can write here 1. Okay, you can write 1 here. Now 1 by 2, this is the formula for work. This is very important. Okay, and this you write down from work energy theorem. Write down from work energy theorem. Work energy theorem. This work is equal to what? Change in kinetic energy. This is change in kinetic energy. Delta, this is delta, it represents change. So what is this? This is called change in kinetic energy. So write down work is equal to change in kinetic energy. So what is the formula for change in kinetic energy? So change in kinetic energy is equal to half m v square minus u square. Make a table. This is the change in kinetic energy formula. But you have to find the kinetic energy. You have to find the kinetic energy. Change in kinetic energy means final kinetic energy minus initial kinetic energy. You can again, you write one thing. This is change in kinetic energy. Change in kinetic energy is half m v square minus half m u square. This is called what? This is called final kinetic energy. Write down, this is final kinetic energy. This is initial, because there is initial velocity, so write here initial kinetic energy. So we'll get kinetic energy formula as half m v square minus half m u square. You write important condition. Important condition. If initial velocity is 0, means body is initially at rest. Initially at rest. Then we have change in kinetic energy. In place of change in kinetic energy, we can write na kinetic energy final. Kinetic energy final minus kinetic energy final minus kinetic energy initial. This will be half m v square minus u. In place of u, you have to put here 0. So anything multiplied by 0 is what? If you put 0 here, so 0 square is 0, and anything multiplied by 0 become 0. So whole together you will get 0 here, and here also initial is 0. So finally kinetic energy is what you are getting? It's half m v square. Make a note. This is half kinetic half m v square, where m is what and v is what? M is the mass, v is the velocity. So in this you have to derive the equation. This is of 3 marks, 3 to 5 marks. Okay, sometime definition will also come. What is the definition of kinetic energy? So you can write in your own way, own language, the definition of kinetic energy. Okay, note down this. And write down definition also, the kinetic energy definition. Write down kinetic energy definition. You write down energy possessed possesses by a body by virtue energy possesses by virtue. Okay, you just make a note. Again you write energy which a body possesses, possesses by virtue of being in motion. Its SI unit is what? What is the kinetic and SI unit of kinetic energy? It's joule. You can write in this way. And CGS unit is urge. So whenever you throw something, that time the body is having kinetic energy. The energy possessed by a body by virtue of its motion. During motion it has some energy. That energy is called kinetic energy. Suppose I throw a chalk. So chalk is having mass, it is having some velocity. So we can say chalk is having some kinetic energy. And whatever we are doing the work, that work is converted into kinetic energy. Here we are doing the work. That work by moving the vehicle from U to V, that work is stored, that work will change into kinetic energy. So work will converted into kinetic energy. Whatever we are doing the work, that work will convert into kinetic energy. Now write down potential energy derivation. Question number 2 derivation. 3 derivations are there. Okay. Second, potential energy. Write down, derive an expression. Derive an expression for potential energy. Derive an expression for potential energy. Expression for potential energy. Potential energy. Or second type of question you can write, prove potential energy. P is the potential energy. Or you can write U symbol also. U represent potential energy. Prove potential energy is equal to M into G into H. You have to prove. This is the question. So write down answer. Let us consider an object. Write down. So write down. Let us consider an object. Let us consider an object of mass m, of mass small m. Full stop. Let the object be BEB, raised, RAISED, raised to a height h, raised to a height h, small h, from the ground, comma, to raise the object, a force must be required. Okay, to raise the object, a force F must be required. Otherwise, how work is going to happen? How ball will move to height h? So you are doing some work. So draw the diagram. You draw the surface. This is the surface. An object is having mass m. You draw. This is object. Its mass is m, and you are applying a force in upward direction. So with this force, it moves to a height h. Small m is there, not capital M. It's a small m. How much height it raises? Up to height h. Okay. Write down, this is a surface. Okay, this is the surface. You draw it. This is surface and this is object. We are applying force. Write down next. Let the minimum force required. Let the minimum force required. Let the minimum force required to raise the object. To raise the object. To raise the object should be equal to. Should be equal to the weight of the object. Weight of the object. So we can write here, force is what? Weight. Now you tell me weight formula, weight of object formula. What is the formula for weight of an object? It's m into g. M into g. Weight formula is m into g. Now you write, let the work done to raise the object BW. Therefore, we know work is equal to what? We know work is equal to force into displacement. Displacement is represented by S. S is what? Displacement. But here there is vertical displacement. Here you can see, here it is vertical displacement. So put the value in place of F, you can write mg, and the displacement is h. So work is equal to what? mgh. Okay, you see here the displacement is vertical. The displacement is how much? H only, vertical displacement. That's why you have to write here h. So this work done, again you write, this work done is stored in the form of potential energy. Potential energy. Therefore, work is equal to potential energy. Whatever you are doing the work, that will convert it into energy. So write down potential energy formula is how much? What is the formula for potential energy? It's mgh. You note down. This is the formula for potential energy. Okay. Last derivation of this chapter. Write down. So you can write the definition also. Write down potential energy definition. Potential energy definition. The energy. Write down potential energy definition. The energy possessed by a body due to its position or configuration. The energy possessed by a body due to its position or configuration. It means whatever you are doing the work, you are changing the position of the object. That work done is stored in the form of potential energy. Here you are doing what you are doing. You are just lifting the object to a height h. It means you are doing some work. That work is converted into potential energy. Okay. Next, last question. State and prove law of conservation of state and proof law of conservation of energy for freely falling object. So first write down a statement of this law. You know this. Write down a statement. In this you write law of conservation, in short I'm writing law of conservation of energy state that energy can neither be created nor be destroyed. Energy can neither be created nor be destroyed, but it can be transformed from one form to other. Okay, it can be transformed from one form to other. This is the statement of law of conservation of energy. Now write down its derivation. Written this. Now its derivation. You have to prove that energy is conserved for freely fall. So write down, suppose an object of mass m is at a height h from the ground. So you have to draw, this is the surface, object is at this height. Here you draw the diagram. This is at height h. This height from the surface this is how much? H. This is an object having mass m. And this is the surface. Okay. Suppose this point is A. After some time, this object will come to point B, and after some time it will come to C. From A to B, write down, from A to B, let the displacement be x. Now you tell me, suppose this hole is h and this is h. So what is the value of here to here? It's h minus x. Total is h and this is x. So h minus x. You make a note here. Note C point is very near to ground. C point is very almost height is 0. Very near to ground surface. Okay, means C is very closer to earth, very closer. Now it is falling under freely falling means write down here free fall, or next page you write, free fall means what? If body falls, or object or body, anything, if body falls under the effect of gravity alone, no air drag we have to consider, that fall is called free fall. Suppose you just drop an object, so it will fall down So there is, if there is air, then air will also exert a drag force in upward direction. Suppose there is no air and you are just dropping an object, that time it will falls under the influence of gravity only. Still there is vacuum, but gravity is present there. Okay, so when a body falls under the influence of gravity only, that fall is called free fall. Okay, gravity alone, alone, alone. Now you write down at point A. At point A, where is at point A? Point A is here. So body is at rest. So write down kinetic energy at point A is equal to half into m into v square. But body at point is what? It is in rest. It is not moving. Since it is not moving, it means its velocity is 0. So put here 0. So kinetic energy is how much? Half m into 0 square. You will get kinetic energy at point A is, write down, it's 0. Okay, kinetic energies will be 0 because at point A it is not moving out up or down, it is just in the state of rest. So if anything in the state of rest, that time we have to take velocity as 0. It is not moving. Now you write potential energy at A. Potential energy, PE represent potential energy at A. So it is mgh. What is the height? H is what here? Write down h is the height from the ground. Always remember this thing, from the ground. Now you find total energy. TE is total energy. You write here T is total energy. It will be kinetic energy plus potential energy. So if you add, you will get 0 plus mgh. So what is the total energy at point A? It's mgh. So everywhere it will be mgh only. Wherever you go, A, B, C, everywhere it is mgh only. We will prove this. Point A will be over. Note down this thing. Now consider with same approach, you have to write at point B. Write down at point B. Easy. Now you tell me potential energy at point B. Its formula is mg. Then height from where? Height from ground. Always take height from ground. Now you tell me, where is the ground? So height from here to here, you see, height from ground to point B. What is the height from ground to B? From ground to B, it's h minus x, not x. What you have to take? H minus x. So better you write here, it will be h minus x. So energy will be mg h minus x. This is potential energy at point B. Write down equation number 1. Next, write down kinetic energy at point B. So what is the formula for kinetic energy? Half mv square. So here it is B. That's why you have to write here velocity at point B. Write down in this way. Written. Vb is the velocity at B. Write down. This is velocity of object at B. Note down. So next write down, we have to find velocity at point B. So how to find velocity at point B? See here. Since the ball is moving from A to B, so here the velocity is 0. You know the formula. Here it is, initial velocity is increasing from A to B. So here the velocity is how much? 0. And here the velocity is, suppose VB. You know the formula, V square minus U square is equal to 2AS. S is the formula for displacement. So final velocity is VB. So you write here VB square minus initial velocity is how much here? Tell me. Initial velocity is 0. That's why here you put here 0. A is acceleration. Here acceleration is due to gravity. Acceleration is due to gravity now, only gravity. Here velocity is changing due to gravity only. If there is no gravity, velocity will not change. That's why we have to write acceleration is due to gravity only. So in place of A, we can write here G. So write here G. So it's G. And what is the displacement from here to here? What is the displacement? It's H. Is it visible? What is the displacement from here to here? It's X. X is the vertical displacement from A to B. So you write here X. So what is the formula for VB square? VB square will be 2GX. So therefore what is VB? Root under 2GX. Or you directly take VB square is how much? What is the formula value of VB square? 2GX. You make a note. Right here VB square. You have to put square above V. Here you have to write VB square. So you have the value of VB square. So put here VB square value. It will be what? It will be half M. In place of VB square, we can write here 2GX. So this will cancel, 2 will cancel, and you will get mgx. So this is what? This is kinetic energy at point B. Okay, this is kinetic energy at point B. Similarly, you find potential energy at B. So what is the formula? mg into height from ground. What is h? We have to take height from ground. Now you tell me height from the ground. You tell me what is the height from the ground? Height from the ground. Height from the ground. It is h minus x. Okay. So what you have to write here? H minus x. So you write here h minus x. So it will be mg h minus x. This is potential energy at point B. Now you have to find total energy. Total energy at point B will be kinetic energy at B plus potential energy at point B. Note down. Put the values. What you will get? Kinetic energy is how much? mgx. And if you solve this equation again, so you will get mgh minus mgx. Now you add up this value, mgh minus mgx. So what you notice here, this is total energy at point B. So this is plus, this is minus, plus minus will cancel, you will get mgh. Where you are getting this value? Total energy at point B. Write down, this is total energy at point B. It's mgh. Now for the same you have to find for C also. This may be a 5 marks question. Okay, all 3 points you have to. Up to this it is correct. Here only you can stop, no problem. Both point we are getting the same energy. What energy we are getting? Total energy as how much? mgh. Previously also mgh. Again you write at point C last. At point C. At point C. You tell me. Kinetic energies at point C is how much? Half m velocity at c square. So we have the diagram. In this way we have the diagram. This is the ground. Object is at height this. So A point, B point, and here it is near to the ground, it is C. So here to here we have to find the velocity. So just remember a trick. I will tell you the trick. Vc square is equal to 2g, the distance from here to here. What is the distance from here to here? You tell me. Distance from here to here. This point is h minus x up to here to here. This is x, this is h minus x. But we are finding the distance from A to C, and C is very near to ground. C is very near to ground. So we can write its value is how much? H. So directly remember this value will be Vc square will be 2g h. Why we are taking 2g h? Tell me. Because this point is very near to the ground. H is very near to the ground. So we can take here, not subtracting anything from height, we just take h. So what is the kinetic energy value? Tell me. At point C, it will be half m. Vc square is 2 into g into h. So g 2 will cancel. You will get mgh. This is kinetic energy at point C. Similarly, potential energy you find at C. Potential energy is mg into height from where? Height from where? From ground. So you tell me the height from the ground. How much height? It is very negligible. So we can take h as a 0. Okay. C is very near to the earth. Very near to the surface. It means height is negligible. It's almost 0.000 something. So you can write here h is 0 here. So what is the potential energy? Anything multiplied by 0 is 0. So you will get potential energy as 0. So what is the total energy? You tell me. Total energy is how much? Total energy at C will be potential energy at C plus kinetic energy at point C. Now tell me, if we are adding this, we will get mgh plus 0. So it will be mgh. So everywhere total energy is same. A point it is mgh, B point it is mgh, and at C point also it is mgh. So everywhere how much total energy? Mgh. It is conserved. So only one form of energy will convert into another form. Potential energy will convert into kinetic energy, energy. Okay. And whatever we are doing the work, that work will be converted into energy. Okay. Last derivation, small one only. Write on power. So write on power is equal to work upon time. Its SI unit is, write down, SI unit of power is watt, W-A-T-T, watt. Okay. And the formula for power you write down. it's mgh upon t. Sometime we have to use power. Another formula for power is, write down, force into velocity also. This is the another formula of power. Second formula, first formula. Third formula, write down, power formula is change in kinetic energy upon time. Fourth formula is half m v square minus u square upon t. Okay, these are the formula of power. Sixth formula you write. Fifth formula, power is equal to energy into time. Energy by energy into time. Here kinetic energy into time power will be. Sorry, it is correct. So power is energy by time also. Okay. These are the formula for power. And last topic you write down, electrical energy. Electrical energy, commercial unit. Commercial unit is kilowatt hour. Okay, only electrical energy is having unit kilowatt hour. Okay, so what is 1 kilowatt hour? Write down, kWh kilowatt hour is equal to 3.6 into 10 to the power 6 joule. How you get this? You write down 1 kilowatt hour is equal to 1 kilo means 1000 and watt means, this is watt, W means watt here, this is kilowatt, and H is hour. So write down 1 watt is 1 joule, what, 1 joule per second, and in 1 hour it's 3600 second. So second will cancel. So how much you are getting? 3600000. So we can write here 1 2 3 4 5 6, 3.6 into 10 to the power 6, how much? Joule. Present in what? 1 kilowatt hour. In 1 kilowatt hour it has how many joule? Write down 1 kilowatt hour have 3.6 into 1 marks question will come. Okay, and kilowatt hour is also called unit. In our home we are getting electricity unit, 5 unit, 6 unit, 7 unit, 100 unit in a month. Okay, that unit is what? Kilowatt hour. Okay, 5 unit means 5 kilowatt hour, 10 units means 10 kilowatt hour. So we will solve the numerical in next class. These are the theories, remaining theories of work, energy and power.